Right. Test paper part A, test paper 3, part A. Right? Yeah. Its first question. Find all real values of x satisfying the inequality. Right. That inequality given x squared minus 1 greater than or equal to mod x plus 1. Right. So we can take this answer in two ways, either by graphical method or the algebraic method. In the graphical method case, we have draw this curve and this curve. Right. I'll first use the graphical method. So you know this graph, when we draw, that graph is y equals x squared minus 1. You know how to draw y equals x squared graph. Y equals x squared graph is a minimum graph. Minimum occurs at 0, 0. We discussed that in the quadratic equation lesson. So therefore, y equals x squared graph is this. Okay. Then y squared x squared minus 1 graph means, right? We have subtract 1 to get this graph. By this y equals x squared graph, we have subtract 1. Subtracting 1 means this graph we have take downward by 1 only. Then this point will be going to minus 1. And the x-axis will be cut by this graph at 2 points. Okay. So then I can draw that y equals x squared minus 1 graph this way very easily. The graph is now like this. Right? Graph is like this. It's a minimum graph because x squared coefficient is positive. Graph is like this now. The y equals x squared minus 1 graph. Point is 0, minus 1. This point and this point. Right. This is minus 1, this is plus 1. Okay. Right. Okay. Now, how do you know this point minus 1 plus 1? You know, when you put y0, x squared minus 1 equals 0, x squared equals 1, x equals plus or minus 1. Of the graph cut the x-axis at plus 1 and minus 1. Right. Okay. And the equation of this graph is y equals x squared minus 1. Right. Secondly, this graph we have draw. When I draw that graph, you know it is y equals mod x plus 1. You know how to draw this mod x plus 1 graph? By using y equals mod x graph, we can draw this one. So here added 1 to this 6 and mod taken. Then by using y equals mod x graph, how to draw this one? Mod x graph. Mod x graph is people, it's a V-shaped graph like this, no? It's a V-shaped graph like this. That mod x graph we have take to leftward by 1 unit because here 1 is added, right? So therefore we can draw the mod x graph this way. This way we can draw the mod x graph. Okay, this is the mod x graph. Right. So then this branch, when I consider its equation going to be, when we define the mod x plus 1, changes at minus 1, no? on the right hand side of minus 1, mod x plus 1 takes x plus 1. No? Therefore, this equation needs y equals x plus 1. On the left of minus 1, mod x minus 1 will be equal to minus of this, no? Minus x minus 1. No? So, therefore, this equation y equals minus x minus 1. Then the two graphs we drew. Yeah. Now, what is asking? This, no? Right. Asking the range of x squared minus 1 greater than or equal to mod x plus 1. This range only asking. That means this black graph is this. That should be above or equal to mod x plus 1. Right. Black graph is above or equal to mod x plus 1. Right. You can see after this point to the right and to the left of this point, the black graph is above the blue. Right now, then you have to find that region. Yeah, first we'll find this point. Let us take this point as A. This point we know already. Okay. Then to find that point A, this point can be found by solving the equation of this and this, because this point A come in by the intersection of this and this. No. Then this equation is x squared minus 1 is equal to here x plus 1. Right. So then we can take this x squared minus 6 minus 2 0. Factorize it. We get x minus 2, x plus 1. Then x is 2, x minus 1. Okay, no? This point definitely not possible to be minus 1 of x. Huh? Yeah, this is 2. Right? This is the minus 1. Therefore, by the graph you can write the solution. This happens. Therefore, x squared minus 1 greater than mod x plus 1 occurs in the interval 1. X greater than or equal to 2. Okay. At 2, they are equal. On the right of 2, black one is above the blue. This happens. Right? And other one is what? X less than or equal to minus 1. Right? At minus 1, they are again equal. So, x less than or equal to minus 1. These are the solutions. Right? In this graphical method, you are given the marks like this. Right. People now here, for this graph, 5 marks given. This graph, 5 marks given. Showing this point exactly correctly, another 5 marks given. No? And getting these two values of x, 5 marks given. And for the last answer, 5 marks given. This is a graphical method. Right? You know, people, we can use another method. That is the algebraic method. Algebraic method. Let's say that algebraic method 2. No need to do by using both methods. What we'll do? Yeah. Right. Second method will come. Second method. Method 2. Okay. In the method 2, I am going to define this mod x plus 1. I am going to define this mod x plus 1. Now, mod x plus 1, when you define, that changes at minus 1 to the right of this x plus 1, left of this minus x minus 1. Then first I take when x less than minus 1. Right. Because this mod x plus 1 changes at minus 1. No? Then this question we have to work out in the intervals less than minus 1 and more than minus 1 intervals. Huh? So there we get this one mod x plus 1. On the left of minus 1, mod x plus 1 takes this. Therefore, this place I have to replace by minus 6 minus 1, x squared minus 1. Then you can take this minus 1 right hand side. With this, we can cancel down, bring this side. X squared plus x greater than or equal to 0. Now take x here out. X plus 1 greater than or equal to 0. Right? Now find the range of this. How to find the range of this? We have to equate this 0. Then we get x is 0, right? x0, ax minus 1. When you equate this 0, we get x minus 1. Since here we have equal sign, both these values we have to take. Right now, substitute a value from this interval. Take 1, put 1 here. Here, it is okay. This interval satisfies. Therefore, this does not satisfy. This will satisfy. In this case, we have to take what? Common region for this interval and this interval. Right? Common region for this interval and this interval. Right. Then what do you get there, people? Right. Yes. Right. Second interval, what for this one you have to take, you can very clearly see here. For this one, x less than minus 1, here less than or equal to minus 1. Right. Then the common interval going to be x less than minus 1, no? X less than minus 1. There we get, no? Right. So what is the second interval? Second interval is when x greater than or equal to minus 1. Right. Now in this interval also, you have to work out the same question, this. Right. Okay. Right. Now take that 2 people and work out that part. Here x less than minus 1 region is used less than or equal to minus 1, less than or equal to minus 1. Then what is the common region? X less than minus 1, no? Take first one as number 1. Second interval, this one we have to discuss. Second interval, when x greater than or equal to minus 1. Right. Right. In this interval, when I work out the question, x squared minus 1 greater than or equal to x plus 1, no? I take this side, x squared minus x minus 2 greater than or equal to 0. Then factorize this. X plus 1, x minus. Right. Then here, what is the interval? Minus 1, here 2. Since here we have equal sign, we have taken the both values. When I put 0, 0 is in this interval. This is 1, this bracket is minus 2, 1 into minus 2 is left hand side minus 2. Does not satisfy, no? So therefore, we have to take this into, no? And this. Right. Now, here, what is the common region? Common region, we get what? So x greater than or equal to minus 1 and this one. The common region going to be what, people? This says greater than or equal to minus 1. Here too, common region going to be x greater than or equal to 2. Right. Then final answer we get by the union of these two, no? Okay. Then final answer, therefore, required solution. We get x less than minus 1 or greater than or equal to 2. No, we have to take finally the union of 1 and 2, no? Yeah. Right, no? Right. Next part is the limit part. Number 2, limit x going to alpha, right? X cube minus alpha cube divided by tan x minus tan alpha. Yes, we can write this one. This x cube minus alpha cube we can factorize by considering difference of 2 cube. X minus alpha. Perspective you can take by neglecting this power 3, delete this power 3, x minus alpha. Second factor will be x squared plus alpha times x plus alpha squared. This is coming by this c cube minus b cube, a minus b, a squared plus ab plus b squared. This way. Okay, now this denominator tan x we write sin x by cos x, tan alpha sin alpha by cos alpha. We can write like this. Now x minus alpha, this part, here take the common denominator as the product of cos x and cos alpha, right? Cos x and cos alpha, when I take this cos alpha comes here, sin x cos alpha minus cos x sin alpha. Then this part you can write. It is sin a cos b minus cos a sin b. It is sin a minus b, no? Meantime, this cos x cos alpha part goes to numerator. Then I can write x minus alpha times cos x cos alpha into x squared plus alpha x plus alpha squared. This part now, sin x minus alpha. The limit going x alpha. Right. Now, this x minus alpha part you can take to the denominator of this. Then I can write 1 upon this is sine x minus alpha divided by x minus alpha. Now I am going to apply limit for this and next one for this and this separately. Yeah? Limit x going to alpha cos x cos alpha. Limit x going to alpha x square plus alpha x plus alpha square. Now this way. Right. Now you know here as x going to alpha, this x minus alpha part is 0. Then here we have sine theta by theta. X going to alpha means x minus alpha 0. No? Theta going to 0. Therefore, this is 1. 1 over 1. Here put alpha, cos alpha, cos alpha, cos squared alpha. Here, alpha squared, alpha squared, alpha squared, 3 alpha squared. Then we get the answer, no? 3 alpha squared, cos squared alpha. This is how we take. Right. Now, the marks come in like this. For the final answer, this is 5 marks coming. And this factorization, 5 marks coming. Next one. And writing this one, 5 marks coming. Right. And this one given 5 marks. And the last 5 marks given for this one. 5, 25 coming like that. Right. Third one, take. A curve C is given parametrically by x equals 3 cos theta minus cos cube theta. Y equals 3 sin theta minus sin cube theta for theta between 0 and 90. So that dy by dx is this answer. Right. Number 3. X given 3 cos theta minus cos cube theta. Y 3 sin theta minus sin cube theta. Here we can differentiate this with respect to theta, no? Because right hand side we have theta, no? Minus 3 cos theta is minus sin theta. Here, first this power we have differentiate 3 cos square theta, then the derivative of cos theta is minus sin theta. Minus sin theta. Then simplifying this, we get dx upon d theta this way. Minus 3 sin theta plus 3 sin theta cos square theta. Now dy by d theta. Here 3 cos theta Then first we have to differentiate this power 3. 3 sine square theta, sine derivative is cos theta. Right, now asking to find dy by dx. Now the marks come in for this 5 marks, this 5 marks. Now we can write this by chain rule dy by dx. Dy by dx is equal to dy by d theta multiplied by d theta by dx, no? Dy by d theta, this is 3 cos theta minus 3 sine square theta cos theta, right? And now this is d theta upon dx. Dx upon d theta is this. In its reciprocal only, here we need 1 over minus 3 sine theta plus 3 sine theta cos square theta. Okay. Then you can take here 3 out. That's why you can cancel on with this 3. From here you can take cos theta out. In bracket we get 1 minus sine square theta. So you can take minus sine theta out. Then this space is 1. We can take minus sine theta out. What do you get there, people? It's 1 minus cos square theta. Correct, no? Then you can see here, plus y minus is minus cos theta. Here cos square theta, 1 minus sin square theta, cos square theta. Here 1 minus sin square theta is 1 minus cos square theta is sin square theta. This is cos square theta, this is sin square theta. Cos squared by sin squared means cot square theta. With this minus cot cube theta coming. Right, for that you get 5 marks. And next one asking. Find the coordinates of the point P on the curve C at which the gradient of the tangent line is minus 1. Gradient of the tangent line. Gradient of the tangent means what, people? Dy by dx, no? Then we need the value of theta for dy by dx to be what? Minus 1, right? Dy by dx to be minus 1. Gradient of the tangent line means, gradient means dy by dx. We need dy by dx to be minus 1. Theta now we need to find for dy by dx to be minus 1. Right. Now, our dy by dx is this answer. Therefore, I can write minus cot cube theta equals minus 1. Cot cube theta is 1. Right. Then, what is cot theta? Cot theta should be 1. Cot theta 1 means, what is theta? What means 1 over tan theta, no? 1 over tan theta 1 means tan theta 1, no? Tan theta 1 means theta pi by 4. Now asking the coordinates of P. Theta we know. But any point on the curve C, x coordinates given by this, y coordinates given by this. Then we can write what? X and y coordinate. Therefore, x coordinate you can write, substituting here pi by 2. Cos pi by 2. What is that, people? 1 over root 2. as we will put here theta pi by 4, right? Pi by 4, theta pi by 4 we have to put. Cos pi by 4 is 1 over root 2. Here cos cube pi by 4. What is that? 1 over 2 root 2. Correct, no? 1 over root 2 to the power 3, no? X answer is this. Then we can furthermore simplify this. Take into root 2. Here 6 minus 1 is 5. Exponent is this. Now y coordinate given by that 3 times sine pi by 4, 1 over root 2, 3 over root 2. Sine cube pi by 4, 1 over 2 root. Then here we get, when you take 2 root 2 as the common denominator, this. Okay. Then point P comes as what? 5 over 2 root 2, comma 5 over 2 root 2. Right. Now, the marks come in for this theta. 5 by 4 is 5 marks coming. Then 20 marks we got, and the final 5 marks come in for this coordinate. Right. Right. Next one, question number 4. L1 and L2 be the straight lines given by 3x minus 4y equals 2a and 4x minus 3y equals 1 respectively. Write down the equations of the bisectors of the angles between L1 and L2. Find the equation of the bisector of the acute angle between L1 and L2. Right. Let's see. Okay. Two lines, L1 and L2. L1 line 3x minus 2y 4y. 4y is equal to 2a. Then I can take this 2a to this left hand side. I can write this like this. And L2, second line. 4x minus 3y equal 1 means minus 1, 0. Suppose the two lines are like this. Asking to find, write down the equations of bisectors of the angles between L1 and L2. Right. What is the equation, people? How to take? We take it how? Right. We take one line like this and divide that by the square root of x coefficient squared plus y coefficient squared. Then equal plus or minus, take other line, this one. Same thing we have to do to the right hand side also. 3x minus 4y minus 2a divided by the square root of x coefficient squared plus y coefficient on this. Okay. This is how we write the equations of the bisector. Then we can cancel down this sign. In taking plus sign, you can write 4x minus 3y minus 1 equals 3x minus 4y minus 2a. By solving this, we get 1 bisector. People, here a slight mistake is done. In the question, the first line we are given as 2a. There should not be a. Only 2 is there, right? That's a huge mistake in the paper, no? Right. There is only 2. And here we don't have a, right? Here also we don't have it. Only 2, huh? Right. Now, simplify this. We get take this side x plus y plus 1 equals 2. One equation is this. The other one take minus sign. You take minus sign, 4x minus 3y minus 1 minus 3x minus y minus 2. No. Then we get 7x here plus and then minus 7y here 2 minus. We get like this, no? 7x minus 7y minus 3 equals 0. Then for this 2, 5 marks given. For this one, 5 marks given. Okay. Find the equation of the bisector of the acute angle between L1 and L2. Acute angle. But a test. There, the test you know, we take one bisector. We take one line given. Then I take like this. Consider the bisector. I'll take this, x plus y plus 1 equals 0. And the line, we'll take any line out of these two we like. I'll take this one. 3x minus 4y minus 2 equals 0. Right. So now this gradient, I'll take m1. The gradient of this is minus 1. The gradient of this is, I'll take m2. That gradient is 3 by 4. Right? When I subject y, then the x coefficient is the gradient. Now what we do is, using this formula, tan theta equals modular m1 minus m2 divided by 1 plus m1 m2. Using this, we calculate this tan theta. If for this tan theta we get the value less than 1, then that bisector we have chosen there is the acute angle bisector. If this tan theta is more than 1, the bisector we have chosen is obtuse angle bisector. That's how we separate. You can remember this here. Yeah. Now I substitute in this tan theta. M1 is minus 1 minus 3 by 4. 1 plus M1 minus 1 M2 3 by 4. Now simplify this. What happens? Tan theta. Here we get minus 7 by 4. Here 4 minus 3 is 1 by 4. Here we get taking the modulus 7. It is more than 1. Then that one x plus y plus 1 is what? The acute angle, no, obtuse angle bisector. X plus y plus 1 is the obtuse angle bisector between the two lines. Therefore, the acute angle bisector going to be the other one. What? This. Right? Therefore, you can write. Right. Hence, this is people now obtuse angle bisector. Then the acute angle bisector is the other one. Therefore, acute angle bisector is this. 7x minus 7y minus 3 equals. Then here the next mark given using this equation, 5 marks given. Final answer given another 5 marks. then the marks we got, this the yeah, after 1 greater than 1. This is 5 marks. And this is 5 marks. Right. That's how we take that one. Then the next one, number 5. Fifth one, show that cos theta by 2 plus sin theta by 2 perfect squared is equal to 1 plus sin theta. Right now, we know square is cos square theta by 2. What a middle term? 2 sin theta by 2 into cos theta by 2. And next one is sin square theta by 2. When I take these two together, sin squared and cos squared, each one, no? Sin square theta by 2, cos square theta by 2, 1. Here, 2 sin theta by 2, cos theta by 2 by half angle formula. What is that? Sin theta. Right? You know this formula, no? Sin A we can write as how 2 sin A by 2 into cos A by 2, no? Right? Huh? Yeah, that answer is okay. Now, ask him to take the answer this. Hence, show that cos pi by 12 plus sin pi by 12 is equal to this. Right now, cos theta by 2, sin theta by 2. Right. Put here theta equals pi by 6. Both sides, because this is an identity, no? This is an identity. So, any value of theta, left hand side and right hand side are equal. Huh? Right, put theta pi by 6. Put here pi by 6 by 2 means pi by 2 will come in. Huh? Here, sin pi by 2. That will power to it. Square, right? 1 plus sin pi by 6. Pi by 6 is 30, no? Sin 30 is half. We get like this. So pi by 12 plus sin pi by 12. Right? Now, here, this is 3 by 2. Right? Here we have perfect square. Then if I need to subject this one, I have to put the square root with plus or minus. Now, left hand side we have cos pi by 12 plus sin pi by 12. Right, people, pi by 12 means what? Pi by 12 angle, it's 15, no? Then cos 15 positive first quadrant, sin 15 also positive first quadrant. This answer positive, this answer positive. There are some should then be positive. Therefore, we reject this minus sign. Okay. Then we select. Therefore, cos pi by 12 plus sin pi by 12 is equal to this. That's the answer. Because the reason is it should be positive. The marks come in here, showing this one 5 marks. Putting theta pi by 6 here, deciding this theta pi by 6 pi mark, and getting this answer pi mark. Okay. Other part is there. Right. Verify and also find the value of cos pi by 12 minus sin pi by 12. Now we put theta here minus pi by 6. Put theta minus pi by 6. Then here cos minus pi by 12 coming. Plus sin minus pi by 12 coming. It's perfect there. Is equal 1 plus sin minus pi by 6. You know, people, cos negative angle, the minus sign, this negative sign we can ignore and write cos pi by 12. Sin negative angle, the minus sign you can take out. That in other words, if the angle contains minus sign, you can take that minus sign out from that if we have sin or tan before it. If minus sign available with the angle with the ratio cos, we ignore this minus sign and write. Then we can write this one as how? Cos pi by 12 minus sin pi by 12, right? Perfect. Add 1 minus half. 1 minus half. Right. This is half. Then cos pi by 12 minus sin pi by 12 to the power 2 is this. Now we can take the square root, we can take on the right hand side. When you take the square root, what do you get? Cos pi by 12 minus sin pi by 12 is equal to plus or minus square root on the right hand side is 1 over root 2. This time, what time we have select? Pi by 12 angle mean people 15 degrees, no? Right. Now, when you sketch cos graph and sin graph both in the same diagram in between 0 and 90 angle, here, cos here 90, cos graph is this, cos 0 is 1, cos 90 is 0 like this, cos graph is like this. This is cos graph. Sin graph, sin 0 is 0, sin 90 is 1. It is like this. You can see they have the same value at the angle 45. Sin 45 and cos 45 equal to 1 over root 2, no? Right? Then pi by 12 is 15. 15 is somewhere here. For the 15 angle, cos 15 here, cos 15 has this height, sin 15 has this height. Cos 15 greater than sin 15. Therefore, this greater than this means we have to again consider positive answer. Understand? Right. Therefore, you can write cos pi by 12 minus sin pi by 12 is equal to 1 over root. Positive answer, therefore we have to consider. Okay. Then what is asking? Deduce that. Sin pi by 12 is the answer. Right. Now we have this number 1, this number 2. Now we take 1 minus 2. Then what happens? Cos pi by 12 and this cos pi by 12 cancel out, right? This minus this, then that will be doubled. 2 sine 5 by 12 is equal to root 3 by 2, 1 over root 2. This is nothing but 2 root 2 root 3 minus 1. Right. So then, for this answer 5 marks. The final answer, this one, 5 marks. That's how we get the marks. Right. They are the pure part. Now we'll come to the applied part. Right. Okay. Applied part. Yeah, it says question number 6 now, right? Okay, question number 6. Okay. A particle P of mass m and particle Q of mass lambda m move with speed u and v respectively towards each other along the same straight line on a fourth horizontal floor. After the impact, the particle P moves with speed v and particle Q moves with speed u in opposite directions. So that lambda 1 and find the coefficient of restitution between P and Q. Right. This way, right. P here, Q here, lambda m, this is same. Move with speed u and v respectively. So this same, this is u, this, right? Right. And after the impact, particle P moves with speed, yeah, after impact, they move in opposite directions. Right. Particle P moves with speed v and particle Q moves with speed u. This way. In opposite directions. Show that lambda equals 1. Right. We can apply just before and just after conservation of linear momentum and Newton's law of substitution. Right. We apply conservation of linear momentum rightward. Then rightward momentum we consider as positive, right? Before the impact, mu, and this is minus lambda m v should be equal to after impact lambda mu minus m v. Can cancel down this m. Okay. Then u minus lambda v, lambda u minus v. So we have the equation. Then by this you can take this to this side, people, u plus v, take to the right hand side, take lambda out, u plus v, this we can cancel down with this, lambda equals 1 coming directly. That's very easy answer. Then applying for the conservation of linear momentum 5 marks, simplifying and taking this 5 marks. Now we have to apply Newton's law of restitution. Newton's law of restitution, we know this, right? After the impact, relative velocity is equal to minus c times before the impact relative velocity. Right. After impact, relative velocity. We apply Newton's law of distribution also rightward. Right. After impact, stop any object you like. Suppose I stop P. Then before impact also we supposed to stop P. When you stop P, apply V rightward, apply V rightward, then this will have U plus V. Right. U plus V equals minus C times before impact, again stop P. When stop P, U leftward, right? And for this also, U leftward. Then this Q will have to the leftward direction Vn plus U, V plus U, right? But we apply NLR rightward, no? Then that U plus V should be negative. Another negative sign, U plus V. Correct, no? Then U plus V is equal to E U plus V, then cancelling this equals 1. Perfectly elastic. Then here marks come in. So this equation given 10 marks. This is 5 marks. Right? This is how we take that. Question number 7 there. A balloon carrying a small uniform ball starts from rest from a point on the ground at time t equals 0 and moves vertically upwards with uniform acceleration f, where f less than g. At time t equals t, the ball gets gently detached from the balloon and moves under gravity. Sketch the velocity time graph for the upward motion of the ball from t equals 0 until the ball reaches its maximum height. Find the maximum height reached by the ball in terms of t, f, and g. Yeah. Right. A balloon, right, this way. Carrying a small ball here. Starts from rest from a point on the ground at t equals 0. Now balloon is rising uniform acceleration f. After time t equals t, the ball, which is already inside the balloon, begins to move freely. Detach means the ball begins to move freely independent of the balloon. By the moment t equals t, the balloon has the velocity v, suppose. Meantime, the ball also having the same velocity v. Then soon after the detach of the ball from the balloon, the ball begins to move with initial velocity v, but under gravity. No longer the acceleration of the balloon coming to the ball. The ball has the velocity v, and now it has to move under gravity with retardation. Then thereafter, the ball is moving upwards under gravity, reducing the velocity. One occasion, the velocity becomes 0. That is the maximum height. So therefore, when you sketch the VT graph, right? VT graph should be like this. Right. From t equals 0 to t equals t, velocity of the ball and balloon both are moving together now. Then acceleration of the ball is same as the acceleration of the balloon because the ball is inside the balloon. Right. So when you move in the bus, you know, when the bus moves, its velocity, acceleration, everything coming to you automatically since you are inside the bus, like that. Ball also getting the same velocity and acceleration of the balloon because ball is inside the balloon until the time capital T. Then it moves this way, right? This way. Then suppose this is the time T, capital T. Okay. Then this angle alpha. This tan alpha gives us what, people? Tan alpha is the acceleration of the ball. This is it. This is the velocity axis, the time. Here, suppose this velocity is v. That is when the ball detached from the balloon, the velocity is v. Thereafter, ball is moving under gravity with retardation. On occasion, velocity coming 0. That motion of the ball moves under gravity with the retardation g. So therefore, Vt graph should be like this. This is decreasing now. This is decreasing like this. On one occasion, the velocity becomes 0. That occasion is nothing but the maximum height of the ball. Then this area from here to here, the whole triangle area only, the maximum height ascended by the what? Ball. Understood? Okay. Then if I take this as theta, what is tan theta? Retardation g. Tan, it is retardation g, right? Right. So then for this graph, 5 marks given. This graph, 5 marks given. Okay. Then yes, we can find, right, by the diagram, tan alpha v over t, right? Tan alpha is f. Then f, meantime use the cross multiplication, v equals ft. This one, okay. Then let us take this time as simple t. Then tan theta, you can write v by simple t. Tan theta is g. V is ft divided by t. Then simple t, subject ft upon g. Now we need to find this area, no? Okay. Yes. Now these calculations given, yes, 5 marks. Then 15 marks come in. Now we need to find the maximum height. Maximum height. I'll take this as OAB. Maximum height given by OAB area. For this 5 marks given. And now OAB area you can write half base P plus P, perpendicular height B. Then for the final answer, another 5 marks come. P is T and simple T is Ft by G, V Ft. Then you can take T out. F over G Ft squared half G plus F Ft squared over. This is the last 5 marks. Yeah. It's number 8. Number 8, huh? Number 8 says something like this. In the diagram, PABCD is a light inextensible string attached to a particle of mass simple m placed on a fixed smooth plane inclined at 30 degrees to the horizontal. The string passes over a fixed smooth small pulley at capital A and under a smooth pulley of mass 2m. The point capital D is fixed. PA is along a line of greater slope and AB and CD are vertical. The system is raised from rest with the spring taut. Show that the magnitude of the acceleration of the particle is twice the magnitude of the acceleration of the movable pulley and write down equations sufficient to determine the tension of the spring. Right? Yes. Okay. This diagram. We have a pulley. Here, P. Mass is mg. This angle is 30. Here 2 mg. The tension here T. Okay, this is P, A, B, C. This is D. Right. First one, show that the magnitude of the acceleration of the particle is twice the magnitude of the acceleration of the movable pulley. Right. So then the easiest way of getting this answer by measuring the length. That's a good solution for this issue, right? So from here, I measure the distance to this level. Let this distance be x. Right. We draw this diagram at time t equals t. At time t equals t. That means what? We first allow the system to move, right? And we release the system to move, and we allow it to move during a time interval t. That moment, what we get, that diagram only we have drawn. Right. So now here, from here, again, we measure the distance to this particle p. That is, suppose y. At time t, therefore, the acceleration of this is x double dot. Here, y double dot. Both this y and x have been measured from fixed point on the ground. Then this x double dot, y double dot, both accelerations are relative to earth. Right. Then you can write the length of the spring at time t equals t. From here to here, y. There's a small part here, that is a constant. Here to here, x. And this semicircumference. This is a constant. And from here to, again, this level, x, right? This also x. And this level to this level, right? Because this level is a fixed level in the earth. This level also fixed level in the earth. Then this height is fixed because this level is a fixed level in the earth. This also fixed level in the earth. Therefore, the height from here to here fixed. Therefore, y plus this constant plus x plus this constant plus x and this constant. They equal to what? Length of the string, right? Then you can write at time t equals t. Time t equals t. length of the string. What do you get there? Y plus x plus another x plus all the constants we can take together as p, and L is the length of the string. Length of the string. We differentiate this twice with respect to time t. Differentiating twice with respect to time t. What do you get? Y double dot plus 2x double dot is equal to 0. Okay. Right. Now, here, if I take this expression as f, right, you can see here, y double dot is equal to minus 2x double dot. And this sign, of course, no need to consider at the moment because we need to show only the sizes, no? Then you can see, right? This says y double dot size, that means the expression of this is what? 2 times the expression of what? That pulley. Okay. Then if you take the expression of this as f, this way, acceleration of this should be 2f, this way, minus 2f. That minus sign is important. Thereby, you can see acceleration of this particle p is 2 times that of this pulley. Okay. But this minus sign, of course, says that's okay. No. So now, when this is moving downward direction, people, this is going what? This direction. The directions are not opposite, but the equation reads that way. Okay. Right. So therefore, we can now say what? The sizes when you compare, acceleration of p is 2 times acceleration of what? That particle. Right. And then that answer you can write. Now asking next one. Write down the equation sufficient to determine the tension of the spring. Tension of the spring. Well, now there are how many unknown? Y double dot, x double dot, tension T, P. Only one equation so far we have. It is this. Number one. Another 2 equations we have to take. The 2 equations we take how? We apply F equals ma for this and this. Then we get the rest 2 equations. Thereby we can solve them. Huh? Yeah. Then you can take this answer. This one, 5 marks given. Then you must write that in word. Therefore, acceleration of P is twice that of movable particle, pulley. Movable pulley. Okay, this way. Now, F equals ma, you have to apply what? For the diagram, also 5 marks given in this case, people. Diagram 5 marks. Then for this one, 5 marks. 15 marks coming. Now, F equals ma, we can apply. Right. Number 1 for P. This we apply. Right. What do you get there? mg sin 30 minus t. Minus t is equal to m y double dot. Number 2. For this 5 marks. Number 2, 2m. We apply downward. 2mg minus 2t. 2m x double dot. This is number 3. Then this one 5 marks. This series. Question number 9, the next. It says in the usual notation, minus I plus 2j, 2 alpha I plus alpha j, with position vectors of 2 points A and B respectively with respect to a fixed origin O. A, B, O, A, O, B. O, A vector given as minus I plus 2j. O, B vector given as 2 alpha I plus alpha j. Alpha positive. Using a scalar product, show that AOB pi by 2. AOB pi by 2. Right. People, AOB pi by 2 means we have to prove this OA vector and OB vector are perpendicular. Right. That means we have to prove this angle is 90, no? Right. To show that one, I take this way. I take OA vector dot OB vector. Right. For OA vector and OB vector. OA vector minus I plus 2j. 2 alpha I plus alpha j. You know, when we have this way, two vectors expressed in ij form, we know how to take the dot product. Multiply I coefficient, multiply j coefficient. Right. J minus 1 and 2 alpha, minus 2 alpha. J 2 and alpha, 2 alpha. This is 0. Then OA dot OB, 0. When dot product of two vectors 0, people that two vectors are perpendicular. This implies OA vector perpendicular to OB vector. Hence, AOB angle is pi by 2. That way you can take the first answer. Right. So showing this one as 0, 5 marks, with 5 marks. Next one, asking this. Let C be the point such that OACB is a rectangle. If the vector OC lies along y-axis, find the value of alpha. Right. Now OACB. Now OA and OB are perpendicular. No? Right. OACB. OA vector minus I plus 2j. OB vector, this one. Then OC vector we can write. Now you know OA CB is a rectangle means this vector and this vector being equal. No? Then this OC vector we can write how? OA vector plus AC vector. OC vector we can write OA vector plus AC vector. OC vector is OA vector plus AC vector. OA vector minus I plus 2j. AC vector is same as OB vector. This 2 alpha I plus alpha. Take this I out, 2 alpha minus 1 times I. Here take this j out, L plus 2. Okay. Right. Now, after this, OC lies along the y-axis. People, now when I consider any vector, suppose if the OXY Cartesian coordinate plane, x-axis unit vector I, y-axis j. When the vector starting from n, O n, line along here, y-axis. Suppose here, this is point 2 or 0 2. Then if I take this point as P, how to write this OP vector? OP vector, how to write people? X coordinate 0, y coordinate 2. In the OXY Cartesian coordinate plane, if we have coordinates of a certain point, using the coordinates, how to write the position vector? X coordinate times I plus y coordinate times j. See here, OP vector lies along the y-axis. Any point on the y-axis has x coordinate 0 and y coordinate particular value. Then how to write the position vector? X coordinate times I, y coordinate times j. See here, definitely the I coefficient should be 0 when the vector lies along the y-axis. I coefficient should be 0. Like that, here also, if this OC lies on the y-axis, the I coefficient should be 0. Understand? Then 2 alpha minus 1 should be equal to 0. Understood? Okay. Then you can write. Right. For this one, people 5 marks given. Then we get 15 marks of ANO. Right. Then you can write when OC lies on the y-axis. When OC vector lies on the y-axis, then 2 alpha minus 1 equals 0 for this 5 marks given, alpha equals half. Correct, no? When any vector lies on the y-axis means ending point has coordinates x0, y particular, then I coefficient should be 0. That's how we take that one. Right. The last question, number 10. Yes, now read that part. Read that question. A uniform rod AB of length 2a and weight W, suspended from a fixed point O by two light inaccessible strings OA and OB, is in equilibrium as shown in the figure. G is the midpoint of AB. It is given that AOB pi by 2 and OAB angle alpha. Show that AOG also alpha. And find the tensions in the two strings. Right. Okay, no? Yeah. Now we are given this way a uniform rod. Right. Here. Right. Center of gravity is at the midpoint. G here. 2y equal. Suppose W the rod is AB. Uniform rod AB of length 2a. Center of gravity midpoint means this is A, this is C. Weight W, suspended from a fixed point O. Right. By two light inaccessible strings OA and OB. Right. I'll take this way. This is tension T1, here T2. Tension. Now, it is given that AOB pi by 2 is 9. And OAB angle alpha. This time. Right. Now, so that AOG also alpha. This also we are asked to find as alpha. Right, people now, how to take this? Right. Who did this part? The geometry here we need. Who did this question? Right. Think like this. You know, when we consider circle, suppose a circle. Right. We take a diameter of the circle. Diameter means the line passing through the center of the circle, meeting the circle at 2 points like this. That diameter, its 2n, when we join to a point on the same circle, this way, the angle between that two lines is 90. This is the circle. Its diameter is this. The 2n of the diameter, we join to a point on the circle here. The angle between them is 90. Right? Then, conversely, when we consider people, display a right angle triangle with the angle here 90, we can draw a circle passing through this three vertices such that this one becomes its what? Diameter. Correct now? Here also the same thing we have here. ABO, here 90. Now, taking this AB as a diameter, when we draw a circle, that circle passes through the point O. Understand? So therefore, that circle, if I draw roughly like this, we get. Right. This is that circle. Right. Its diameter is AB. Midpoint of the diameter is G. Midpoint of the diameter means the center of the circle. Okay. Therefore, of that circle, G is the center. Then you can see people, the radius of the circle being equal. No? Then this also radius. This also radius. Then this length and this length must be equal. Why? This is the radius of the circle. This is also radius of the circle. These two sides are equal. If these two sides are equal, people, the opposite angles, this and this must also be equal. Therefore, we can say this also alpha. That's how we have to explain that. Understood? All right. Then we'll write that this way. Write down like this. Write down. If the circle is drawn, with AB as a diameter, that circle passes through the point O. The circle passes through the point O. Its center is G. Its center is G. Therefore, GO equals GA. GO equals GA. Hence the angle AOG alpha. Hence the angle AOG alpha. AOG alpha. Right. People now for the diagram 5 marks given. For this one, explaining this way and taking this angle alpha as AOG 5 marks. Now asking to find this T1 and T2. Right. T1 and T2 you can take like this. Now this rod is in equilibrium now. You know, when any object is in equilibrium, we can resolve the forces along any two perpendicular directions. Usually we take that directions as horizontal and vertical for our convenience. The two perpendicular directions can be horizontal, vertical, we take as our convenience, any two directions, any two perpendicular directions. Now we resolve the forces along this direction and perpendicular this direction. Write down. Considering the equilibrium of the rod, resolving forces this direction people. AO. AO direction, what is the force? P1. By this T2, what do you get? No, we won't get by T2 because T2 and T1 are perpendicular. When you resolve this direction, T1 coming, but T2 doesn't give. By this W, this direction cos alpha. Then T1 equals W cos alpha. And secondly, we resolve this way. BO direction. What is that? T2. By W along that direction, away from alpha, find alpha, W find alpha. All right. People now for this one, 5 come in and write in this way, resolving the forces for that one, 5 marks coming. Okay. This is how we take that answer.